IT. So we covered the Spark interview questions. So we covered the basic to advanced each and every question in our detail. So there is the one question, performance optimization and tuning. There is the one important question, and what is that? So I will be cover that debugging troubleshooting questions, right? So how would you debug fix java.language out of memory error, Java heap space in a Spark job? I will tell you how to solve this question. This is a very important question when you are debugging any real time uh, problem, Spark problem in the project. So I will tell you. So first we identify why this issue is occur. Okay, when encountering Java language dot out of memory error, Java heap space, right? Basically, when this issue is occur, when this issue is coming in the problem statement, basically when encounter Java language out of memory error, Java heap space in a Spark job, the issue is usually related to improper memory allocation. When you not allocated driver memory, worker memory in a no, in a proper way, then this issue will occur. Otherwise, excessive data processing. So the used data set, you took very small size of memory for the driver and worker node, and the data is very used. So the we are driver node and worker node not able to handle the data, right? So this issue is occur, excessive data processing, inefficient transformation. Definitely you will get inefficient transformation, right? uh, Inefficient transformation you will receive, then transformation is not efficient to perform to transform the data. We have a less memory and less cores in our driver and worker node, so we are not in worker node, so we are not able to process the data. That is called inefficient. So I will tell you how to step approach debugging and fix it. Identify the cause before fixing the issue. Determine what is consuming too much memory, right? Identify the issue cause. So first, before we need to identify fixing the issue, determine what is the consuming too much memory. We need to check the driver log and executor log for stack stress. Identify which stage or task is failing. Check the Spark UI for skew partition. High memory uses long running tasks. Till now, I think this is a very clear statement. I will tell you again, I can repeat again. Before fixing the issue, determine what is the consuming too much memory. Check the driver logs, where in the driver logs we can see, oh, these are the issue, these are the problems. We can identify, oh, these are the logs. Check the executor logs. Oh, these are the logs as a issue. We need to check it. Then like first identify which stage, because we know Spark create the stage or task is failing, so we can say group by task is failing, or stage, so we can identify stage and task, which stage and task is failing. Check the Spark UI for skew partition. Now we need to check the Spark UI for skew partition, right? High memory uses or long running tasks. So we need to check the Spark UI. We have to check the Spark UI for skew partition. Oh, what are the skew partition? We know skew partition means the uneven partition. That is a skew. So we need to identify uneven partition. Even we need to identify high memory uses, which stage and task is taking high memory, which transformation is taking high memory. Or we need to identify long running task, which is the long running task. So we need to identify. Optimize spark memory allocation. This is second way. We need to optimize spark memory allocation. So first, always increase the executor memory. If executor don't have enough EV space, so increase the executor memory. So how can we increase? We can increase --. We can run this command in cmd and spark when we are running spark locally --executor -memory 4G. Similarly, increase the driver memory. Now increase the driver memory if driver run out the EV space. Now increase the driver memory if driver does not have enough memory, right? So we can increase the driver memory by -driver. Increase the heap space for JVM. Now we can increase the heap space for JVM. If we using Spark on yarn, increase the JVM heap size. All right, this is the way. Third option, optimize the data processing. So there is the way we can optimize. Reduce the memory uses, right? Use the columnar format like 𝗲𝗃 instead of CSV or JSON. But this is the another way we can use the memory uses. We have to choose the format which is taking a less memory. So we knew that columnar format like 𝗲𝗃 and ORC is the columnar format which is taking a less memory, because we are writing something, we are reading something, it is more faster. Use efficient data type, right? Avoid string, use integer when possible. Okay, so I would always suggest use efficient data type like string, use int. So we know string take up most of the occupy, right? So use integer when possible. When we use instead of the integer number of column, we have to use the give the integer. We don't need to give the string. Avoid the collect and two pandas. We know that they bring the data to the driver. Also the same thing, if you are using collect or two pandas, they bring the data into a driver node. So you don't use the collect and two pandas. Use persist. If your in memory is very tight, we have less space in memory, use persist disk only if memory is tight. Optimize shuffle operation. So we knew that this is another way. This is a part of optimized data processing. So I'm giving you a few examples. Optimize shuffle operation. So I would suggest you, shuffle is expensive operation. We knew that. Reduce it by. So repartition wisely, right? When you use this Python code df.partition and adjust partition count based on the data size. So always you use the repartition, adjust your partition count based on the data size. Let's suppose your data is less, you make 100 partition. This is not right. Your data is high, or you keep 10 partition. This is the good. So you have to adjust partition according to your requirement. Avoid group by if possible. Use the reduce by for aggression. I would suggest you, there is a two option: avoid group by key and reduce by key. Try to use the reduce by key for aggregation instead of group by key. This is one interview question we have. What is the difference between the reduce by key and group by key? I will explain in that. But here I would suggest you use the group by key if possible. Use instead of use the reduce by key if possible. Otherwise, try to ignore the group by key for aggregation. Use map partition instead of map to minimize the function call. So we know that what is the map partition. There is another interview question we have. In the further you will get it. What is the difference between the map partition and map? So where you will get difference between the map partition and map. All right. Optimize join. Use the broadcast join for a small data set. This is why what is the use of broadcast join we already discussed. Optimize join. Use the broadcast join for a small data set. For 𝗲𝗼𝗁𝗏.SQL.function import broadcast df.large.join broadcast df_small key. Ensure that data is partitioned correctly before joining. Till now, any doubt or not? You can put the comments if you have any doubt. You can put the comments if you have any doubt. I will try to make it as easy and explain in more easier way. Right? These are advanced concept, but you have to like. Broadcast join, we know that one is the smaller data, one is the large data. So we have to broadcast for the smaller data because there is an interrogation we have already. But what happens with the broadcast when you do a smaller data or a smaller variable? It will broadcast each variable, each worker node. It will go each worker node. I would say use the broadcast. Ensure the data is partitioned correctly before joining. The data will be partitioned correctly in each worker node. Tune Spark configuration. Tune Spark configuration. Tune means try to Spark configuration, adjust that Spark configuration basically. So increase the shuffle memory fraction. Increase the shuffle memory fraction. We can increase the shuffle memory fraction. --conf spark.memory.fraction equal to 0.8. Use the spill to disk for large shuffle. Right? Spill to disk for the large shuffle. There is the large shuffle to use, their data will be spilled. So spill to disk. Right? So we can increase the dynamic memory allocation. So if there is a large shuffle, it will be spilled to disk. So we can increase the executor memory. So we can avoid the spill to disk for large shuffle. Use garbage collection tuning. Now we can use the garbage collection tuning. Enable the GIC better memory management. So So there is the way use garbage collection GC tuning. So enable better memory management. So we can enable the garbage collection GIGC G1GC. So Spark executor dot extra Java option equal to hyphen hyphen double x colon plus use GIGC G1GC. So basically we can use that way. Reduce the GC overhead with Spark executor dot extra Java option equal to hyphen double x colon plus use string duplication. So these are the taking care of the jar action. There is the another video where we explain the what is this garbage collection in detail. But currently we can keep this one, right? Don't worry. This will be in the another introduction. You will get it. Check for the skew data. This is one of the important problems. Skew data, uneven data. If view partition and most of the data, use sorting. So sorting technique to handle the skew data. So for PySpark SQL dot function import call random df dot with column salt rand dot 10 random number 10 cast int repartition salt key equal to salt. So we can distribute the data. This is a way sorting technique. If you are using the Databricks, so this is sorting technique. There is another video I will tell you where we explain the what is the sorting technique, why we use that, how can we take care of it. But currently I will give you use the sorting technique. If you are using Databricks, enable the Photon engine for optimized execution. Do you know Photon engine? I will explain in another video where we use the liquid clustering, use auto optimization, Z ordering and indexing, or liquid clustering also. Enable the addictive query execution. True. So these are the things we need to take care. We are doing while we are doing debugging, troubleshooting. So summary and issue and solution. Heap space too small. Increase the executor or driver memory. This is the issue and I give you the solution. Summarize, I think I will give you. If you have an issue, heap space too small. Increase the executor and driver memory. Excessive shuffle. Reduce the partition. Use the broadcast join. High garbage collection overhead. Use the G1GC. Reduce the memory pressure. Large data set in memory. Use persistence. Avoid the collect. Skew data. Repartition or use salting. So please use this technique. I will be come with another question, but this is one of the question. Thank you. Please like, subscribe. Let me know if you have any doubt. You can put the comments. I will be try to give you answer. Thank you.